So today's class we are going to discuss is called the overview on the basic electrical engineering. So before going to that, I will write one term. It is called that electricity. Electricity. So this is the word is familiar for everyone, that electricity, and this electricity used for the different applications is like lightning purpose, heating purpose, heating, and traction applications, and countless. You can say the countless purpose or countless applications. So many applications we have, countless. We can say that different applications of this electricity. So when if I say this electricity and our daily life is start with electricity, and we are going to the bed also, that will be going to be end up with this electricity. Even you are sleeping also, that is you are depends on that electricity. When you are sleeping, you are going to on your air conditioners and fans and other not. So different application, because we can't imagine that without this electricity, our daily life cannot be move forward a bit. And you can also think about, if the electricity is not discovered, then what could be the scenario in our world, and as well as for in our daily needs. And in that aspect also we need to imagine. So this is the basic, it's a very important subject electrical engineering. And this is what going to it is going to deal with a different concept and whatnot. So if you are an electrical engineer, so what could be we are going to do here, electrical engineering. So before going to study this electrical engineering, we need to understand the basic concept of this basic electrical engineering, the basic concepts of this electrical engineering. So further, after understanding that, further you can carry forward our electrical engineering subject. So this is the main purpose of introducing this basic electrical engineering in the first year itself, for all the B.Tech level, to have a minimum idea about that basic, what is electricity, and how these different electrical elements we have, and how they are going to working and their working principles, and how this electricity has been generated, and what are the different applications we need to understand. So that is the main purpose of this basic electrical engineering, which is introduced for different streams in first year itself, for the whenever the students are entering into that institutions. Now comes to we'll see the syllabus of this particular subject. This subject is 3 credit system, 3 credit subject. It is a 3 credit system subject. It is. Now we'll go for the syllabus here. Now, what are the syllabus we are going to study in this basic electrical engineering when you are going through this particular subject? So first we are going to study here. It is DC circuits. So we are going to study DC circuits. And the second concept we are going to study is called that AC circuits. And the third concept we are going to study is the magnetic circuits. And the fourth concept we are going to study is the transformers. So what are the transformers and what, and next that concept is that we are going to study is the DC machines. So DC machines, and we're going to study that another concept is induction machine induction machines, and the final concept we are going to introduce in this particular subject is called measurement and instrumentations. You can say measurements and instrumentation, and that last but not least, this is the last one we are going to study is illumination. This was the final topic we are going to study in this particular subject. Now come back to here, in case of this first topic, the DC circuits, we are going to deal with that Ohm's law here. We are going to deal with that Ohm's law, Kirchhoff's laws, different Kirchhoff's laws, the KVL and KCL we are going to deal. So what are these Ohm's law, what is definition, and what is meant by this Kirchhoff's voltage law and Kirchhoff's current law. So those kind of concept, and we're going to explain here, and then we're going to see that different applications of these particular laws in this particular DC circuits, and we'll do some numericals based on those laws. Then we'll go to for that topic, it is called the superposition theorem. We have the different theorems we have, but one important theorem, this is the basic theorem we need to understand when we are in the first year. This is the superposition theorem. What is the statement of that, and how this superposition theorem is going to be applied in this particular circuits we are going to deal in this case. And then we'll go for the star delta transformation. So star and delta's transformation, star delta transformation, it is called the star and delta transformation. And how for a given network, how we are going to, suppose the star network is given, how to convert into the delta network. If delta is given, then how to convert into the star network. So those concepts we're going to deal here, and then we'll going to further, we can take one or two numericals, and we can easily going to explain this particular concept here. Then finally we are going to see here that nodal analysis, nodal and the mesh analysis. So these are the two concepts we are going to see. What is meant by node, and how to define the node, and what is meant by mesh, or how to define that, and how we are going to use this application, this particular concept in this particular DC machine. That kind of things we are going to see under this DC circuits. Now we'll come back to that this one here, and we'll come back to this second topic in the AC circuits. When we are going to see this one here, we are going to see that complex representation of the impedance, complex representation of the impedance. So this concept we are going to see, and the phasor diagrams, and then we'll go to see what is meant by power, and what is meant by power factor, and we're going to see how to measure the power factor, how to measure the power here. So how to measure the power. So this concept we are going to study here. The complex representation, if you have that impedance, what is meant by that impedance, and how this imaginary and real part is going to be represented, and then also we're going to see that phasor diagrams, how that currents and voltages leading lagging with respect to each other, and in case of inductive circuit, what is happening to current and voltage, how they are going to be leading lagging, and what is the concept. Then we will going to deal with this power. What are the types of power we have? Real power, reactive power, and apparent power, and how they are related to that terminologies, and then which one is useful, and how this power has been generating inside the circuit. So this concept we are going to see, and the definition of the power factor, and its dependent factor, how this lagging power factor, leading power factor, and inductive power factor, what do you mean by that. And then we will see for different loading conditions what could be the power factor is going to be, whether it is going to vary or it is going to be constant, and this kind of concept we are going to study here in this case. Then we go for the measurement of the powers here. Active power or measurement of active power. So here the techniques, different techniques we have. So in that we'll go for the 2-watt meter method, 2-watt meter method, and 3-watt meter method. So these two techniques we are going to use, and we'll to measure the power in any given networks. That concept we are going to study here. So this is all regarding this AC circuits. So this here we'll going to see the AC circuit for single phase as well as for 3-phase circuit. We are going to deal here. Moreover, if you see the classification, one more classification you are going to see here: series AC circuits and parallel AC circuits. So these all concepts we are going to study under this particular AC circuits, and with that this particular topic can be completed in well and in a stipulated time. We can go for that if we do very better way. Then that comes to that next part. We are going to talk about the magnetic circuits here. This magnetic circuits, we are going to see the fundamental of magnetic circuits. We are going to see the different terminologies we need to understand here. Then we will go for the fundamentals of magnetic circuits here. So what are the fundamentals? Fundamentals of magnetic circuits. And then we'll go for the concept fundamentals. Then we'll go for the concept of mutual and self-inductance, inductance, and then we'll go for the coefficient of coupling. What are these concepts, and how these coefficient of couplings can be done in this particular magnetic circuits. We're going to deal here. Then we also do one analysis is called that the analogy between electrical network versus magnetic circuits, magnetic network we can say. So when you are going to see magnetic circuits and electrical circuit, what is the difference between these two, and how they can be similar to each other, and those kind of terminologies we are going to explain in this particular concept, and we will go to do that one. Now come to here. On the fourth topic we are going to see here. So when you are going to see the fourth topic here, so we need to understand what is the transformer. So here we will basically go for the operation of the transformer. How these transformers is going to be working. You can say the working principle of the transformer, how this transformers working, and then we'll go for the constructional details. We go for the constructional details. And we'll go with the EMF equation. EMF equation, then equivalent circuit of the transformer, equivalent circuit of these transformers, then different losses in the transformer. What are the different losses in the transformer? Different losses, then efficiency regulation, efficiency and regulation. So all these concepts we are going to see in this case of this particular transformers, and this especially we are going to deal with this particular transformer is single phase transformers. Only for single phase transformer we are going to study all this concept, and we can restrict it to only single phase transformer for your this particular subject. Now comes to this particular fifth content, that is DC emissions. When you go for the DC emissions here, we will see here, and yeah, when go for the DC emissions again, we have that we can say the operating principle, how your DC emission is working, operating principle. So this, what are the operating principle? Faraday's law of electromagnetic, Faraday's laws, how this, and how this laws is going to be working, and how your conductors are inside the your DC machines, your rotor is running. So those concept we need to understand here. Then we'll see some constructional diagram. Constructional diagram here we're going to see, and we'll see the classification of the machines, classification of the different machines we have, shunt DC machine series and shunt and series, and long shunt and short shunt, compound motors. So different types we have. We'll see what are the different classifications. Then we're going to see the characteristics of these DC machines. Characteristics of DC machines. Then final topic we're going to deal in this particular module, that is, you can say the speed control techniques. So speed control techniques. So what are the different control methods we have in order to control the speed of the DC machine, and what are the possible ways, and which one is more appropriate one, and so for different application which method is going to be used for which application. So those kinds of concept we will going to study here in this case. And now comes to that third one, this is sixth one, this here induction machine. Same, the induction machine, it is also called AC machines. You can say AC machine. It is in the operating principle. Again, we are going to see what is the working principle of this particular machine, and then we will see the classification of the machine, classification and constructional diagram. And then we'll go for the speed torque characteristics. And some basic concept, what is meant by slip, and some starting torque and running torque. So those kinds of concept also we will cover in this induction machine. So the very basic idea, we're not going a very depth of the induction machine. Anyhow, when you are in the second year or third year, when you come to that level, so you will be going in very deep in this particular machine. So we will cover here a very basic idea and very basic terminologies, and we will introduce the concept here. So now comes to that one more module, that is we are going to deal here the measurements and instrumentation. Measurement, and we go for the instrumentation here. So here what we are going to do is when you have the AC quantities, so your voltages and currents and power, so how are we going to measure? So you need obviously some meterings, you need the meters, you need instrumentation you need. So in this concept we are going to see some different types of meters, that is ammeters and voltmeters, which have been constructed using the moving iron and the moving coil. So these constructional details we're going to deal here. So moving iron means what are the constructional parts is going to be required for this in order to develop this voltmeter and ammeter for moving iron, and moving coil, what is meant by this, and how this moving coil ammeter and voltmeter working, and what are these special application, which one is used for which, whether you are going to use for AC or DC supply. So those kind of things we're going to clarify here, so that you will have an idea that which one has moving coil has to use it for AC or DC, and uh, moving iron is going to be used for that this AC and DC. So we'll see how this metering construction has been given, and particular application we're going to learn in this particular module. Now come back to that final one, the illumination part. So here we are going to study the different laws of illumination. Different laws of illuminations we are going to study here, and a very basic definition we are going to see here. Very basic definitions, and their units, and what are the basic illuminations, laws, those kinds of things we need to deal in this last module we are going to deal. So this is what the total topics we are going to cover in this basic electrical engineering. So this is what we're going to deal in the coming classes. Now comes to the after study the basic electrical engineering. So after studying all these concepts, so what are the course objectives? What are the course objectives, or what are the course outcomes expected from the students? The first the first objective or first outcome of this course is, so the student is able to analyze and solve electrical and magnetic circuits. This is the first outcomes you can expect from the student. He is able to analyze and solve any electrical and magnetic circuit. The second one is, he is able to identify, the student is able to identify the types of machines for a given application, So we are going to study the different machines here: transformers, DC machines, and induction machine. So which particular machine is going to be applied for which particular applications? Those kinds of that knowledge can be gained by the student when at the end of this particular syllabus completion. Now, third outcome can be expected from the student is the recognizing the ratings of various apparatus. That is the another outcome, and one more outcome is that, so identifying the metrics, identifying meters for measuring electrical quantities. So as we know, we have different meters, ammeters, voltmeters we have, and watt meters, and different power factor meters, and some other meters we have. So tachometers, some we can say example. So basically, when you are after studying this, what is the purpose of meter, and what is the purpose of voltmeter, what is wattmeter, how they are going to measure that particular basic quantities. So those kinds of knowledge can be absorbed by the any student after completion of this particular basic electrical engineering this subject. So with that, I will conclude this session, and the next class will going to start. We're going to start with that basic knowledge of this particular DC circuits, where we're going to start a very basic concept of these different laws and Ohm's law and KVL KCL, and we'll see what is meant by this, and then we'll start our sessions in a very safe manner and very smooth way.